First of all, thanks a lot for the OreTeam to organize such event and provide the platform to share the knowledge and technology to the industries. Special thanks to Srinivas Rao to show the mirror to the people here for the facts of behind the scenes. And ladies and gentlemen, good morning to all. Proceed for the technology part. As a producer gas is generated by coal gasification, which is most viable substitute of expensive liquid and gaseous fuel in 21st century. Now, what is the gasification? That is thermochemical reaction that convert any carbonized material into combustible gas known as producer gas or syngas by using heat. The ultimate, it is the game of partial oxidation of carbonized material. The equipment that convert carbonized material into the gaseous fuel called as gasifier. This is for your confidence and strong references. We take little bit in history and footprint of coal gasification technology in the world. The coal gasification technology has been invented in 18th century, but industrialization has been done in early 19th century by a German company named Lurgi. The first two-stage coal gasification developed by Foster Wheeler Energy Corporation, New Jersey in 1905. The first coal gasifier installed in India, Jalgora in 1936, it is in Ranchi by the name of company Lurgi, and it was fixed bed updraft single-stage coal gasifier. And Asia's largest coal gasification batteries still running in Ranchi, Heavy Engineering Corporation since 1965, and all are two-stage coal gasification supplied by Skoda Yugoslavia. The 10 numbers of extended shaft coal gasifier still running in BHEL Trichy since 1976, supplied by Rohrgas, Germany. The technology has proven track record and successful replacement of industrial fuel like HSD, FO, SKO, LPG in all applications like direct and indirect heating equipments. All over gasification technology is India's most viable substitute of expensive liquid and gaseous fuel in 21st century. And as India is rich in coal, which is third largest reservoir of coal in India, so ultimate raw material of the such equipment is only the coal. So you have to be dependent on all on Indian fuels. The bed and underflow is a large scale investment as well as it is for the larger consumers. For the fixed bed, it is again divided into three types of coal gasifier. It is updraft, downdraft, and cross draft. It is according to the S and air direction. It is done by the entrance of air and generation and direction of the gas. So we take in the deep look of updraft coal gasifier. In that there are another three parts: single stage, which is known as a hot gas offtake coal gasifier; LTC shaft, which is 100% top offtake low temperature coal gasifier; and double stage. We have in a two gas offtake. We later see in the slide the detailed presentation. This is a typical reaction. Fixed bed updraft coal gasification is started from the cold feed, which is called travel to the downward, and the gas formation is to be started from downward to upward. So this is co-current reactor. Whatever the air and steam mixture, we inject it from the bottom of gasifier, and once first it is reacted over here, it is oxidation zone where the carbon and oxygen react, form to CO2 plus release the high amount of heat. With this use of this heat, H2O molecule react with carbon, convert into CO and H2. Later on, it is entered into the reduction zone where major gas component is formed. The CO react with 3H2O, convert into the methanization, convert CH4. 2H2 react with carbon, convert again CH4. Like this, there are more than 20 reactions in reduction zone. Once the gas is formed, it is entered into fresh coal, which is come from the top, where it's contain the volatile matter is driven off and come out with the gas stream. The amount and the quality of that volatile matter is ultimately depend on the temperature of gas and condition of the beds inside the reactor. At low temperature parameter, having delivery fairly clean and chalk-free gas, easy operation maintenance, suitable for long distance distribution of producer gas and continuous operation. You can see the reactor and its line diagram for the entire process. Because the reactor having self-producing steam facilities, whatever the steam is generated, collected in the vapor drum, then distributed into the entire plant wherever it is required. This is coal feeding for fully automatic with the boil con arrangement, which discharging coal according to set temperature. Whatever the gas is generated pass through the primary scrubber, where we can clean the gas, and it is suitable to replace the furnace soil. Then after, if we require further cleaning, it can be passed through the filtration train that we'll see in the later slide. Whatever the scrubbing media, it is 100% recycled. There is no kind of drain at all in the plant. And tar which is collected over here is stored into the storage tank. We intro to double stage coal gasification system. This is design reference taken by Waddell-Deckham process. In the double stage gasifier process, gas come out from the two outlet of the reactor. From lower outlet, and from the lower outlet, hot and low calorific value gas is produced with a less tar content, and from top outlet, high calorific value gas with a low temperature tar is produced. This type of gasifier is specifically designed for gasifying bituminous of coal. After all, we blend both the gas in a single pipeline, and calorific value is little higher than all single stage coal gasifiers. It has good environmental protection performance, and the volatile matter in the coal is removed in the pyrolysis zone, and light oil is produced, which is furtherly cleaned and stored into the tanks, and it can be used as a furnace oil also. The strength of the technology is high calorific value gas, better efficiency and good environmental protection, and weakness of the kind of technology is only high grade of Indian coal, having swelling index number up to 2 can be gasified efficiently. And this is the schematic diagram. As I said, there are two collection points in the reactor. The first zone is very close to the grate. Whatever the coal is reached up to here is already devolatilized. So the gas is released from here is been hot at for 500 to 600 degree centigrade, containing carbon and hydrogen formation. The all volatile matter is driven off from the upper stage, which is the gas temperature that we are getting over there is 120 to 150 degree. Then we will pass this gas to the filtration system to collect the all volatile matter which is in vapor form, as all the dust, and then after all the pass through the ETP for ultra clean stage. These are the some arrangement, tentative arrangement for fulfill the larger demand of the gas volume. We can battery this kind of gasifier up to 20. This is the ultra clean scheme of coal gasification reactor. This is the LTC shaft coal gasifier, the primary scrubber, then secondary. We condense the gas over here before injecting in the ETP. Then after it is from the ESP, WESP, the gas is in the minor impurities and travel to the end user equipment. NTWESP with 3-phase power supply and microprocessor based control system is to be first time in coal gasification industry using 3-phase power supply module, and it is entire control through the microprocessors. The working principles of the ESP is the electron emitted from the discharge electrode, which have been charged with the rectified negative high voltage. As you see, the blue corona is here, having a negatively charging gang here, waiting for the all positive molecules, which having normally molecules are positives, which having dust particles, all hydrocarbon vapors, impurities with the gas flow. Once it is entered into the environment of high static corona fields, convert into the negative electron stick with the dust particles and become a negatively charged. The electric field transport them to the earthen collecting electrode where they are deposited. So ultimately at the end, gas is completely clean. What is the microprocessor based control? As I say, the circuit diagram here is first off is the power supply start with step up transformer with fully protected earth switch and isolator switch. I likely for the benefit sustain the high surge load and also provide the earth switch for maintenance purpose. Then after it is full wave bridge rectifier controller convert the AC current to high voltage DC. With the full wave 3-phase, we get the pulse width of 3.3 millisecond, which improve the efficiency and life of the discharge collecting electrode. And ultimately, because of 3-phase and very less pulse width, we convert into the we will take the kV average is 20 to 25% higher than traditional single phase power module. The current limiting reactors unit monitoring the current supply. The thyristor control and current limiting simultaneously work in the event of arc formation, and arc is resolved within the 3 milliseconds to protect the equipment, and power is restored immediately. The entire system is controlled with microprocessor based fully automatic control, so no need very less interface of human during the process. Like in traditional, there is a toggle switch, the operator need to be monitoring frequently. So this is a completely automatic control. Here some of our installations of the coal gasifier. This is ultra clean series of coal gasifier, reactor, then filtration system, weight filtration system, then pass through the ESP and deliver gas to the end users. These are the some of few. These are the load LTC shaft coal gasifiers. It's the high temperature coal gasifier installations. This is also high temperature. This is our filtration train. This slide shows our control panels. First photographs, our booster panel modules, MCC panels, and this is microprocessor based control for WESP. This is a gas distribution train. This is a distribution headers, and this is in ceramic. This is both are ceramic, and this is in steel industry. This is, you can see the pilot frame over here, the richness of the gas by judgment. Here we collected tars from the WESP. It is similar to furnace oil, easy to handle as well as store and use in place of furnace oil. This is our continuous fuel feeding system. The ultimate conclusion, the worst coal with the route of gasification convert into the clean producer gas result in reduction in the fuel cost up to 30 to 60%, make considerable saving in production cost. The lower production cost result into the higher profit. Thank you for your attention.